Welcome to this 7th module of the course Cloud Computing. In the last module, we saw that distributed systems is one of the underlying technologies for cloud computing. We saw the basic definition of distributed systems, and we also clarified that distributed computing and distributed systems are the similar concepts. Further, we saw the essential characteristics and the design issues of a distributed systems. Also, we looked at the influences that gave rise to what is known as cloud computing today. We saw that we started with mainframe computing, and then the concepts of grid computing, cluster computing came, and then the concepts of grid computing arrived. So, this way we came finally to the current age of cloud computing. So, in this module we will see how the communication happens in a distributed system and therefore in cloud. So, let us look at what is communication. Basically, communication is nothing but interaction between two processes. Not only two processes, also any and all entities that are part of a distributed environment or any environment for that matter, when they try to communicate with each other or interact with each other, we call it a communication. Now, in a uniprocessor environment, this communication between two processes or two entities is very simple. Why this is simple? Because in an uniprocessor environment, there is what is called a common memory, which means that they have a shared memory space, which is the address space of the computer where both the processes are running. Since there is a common address space, therefore, it is very easy for the operating system to assist in making two processes running to interact with each other or communicate with each other. And a typical example for an uniprocessor system where two processes communicate with each other is the producer consumer problem. In a producer consumer problem, one of the processes writes in a buffer or produces and stores in a buffer, and the other process reads that buffer. So, in such an environment, what happens actually is the data generated by one process is passed on to the other process by the method of writing in one particular predefined space in the memory, and then allowing the other process to read from this particular space in the memory. This is called a buffer, and this buffer is typically used by both the producer process, which is generating the data, and the consumer process, which is using the data to access, although at different times they cannot access this shared memory at the same time. So, this typically gives rise to the synchronization issue. When the producer is producing, if the consumer tries to access during the method of producing or in between the production, there arises a problem of synchronization. There is a situation where there is an incorrectness in the environment, and this has to be this is to be corrected by the operating system, and typically the operating system uses the semaphore for this correction. So, now in a distributed environment, this process becomes particularly hard. Why this process becomes particularly hard is because there is no shared memory. let us understand this process, this concept that there is no shared memory. In a distributed environment, we understand that different processes run in different machines, and these machines will be perhaps geographically in different locations. So, when we say that these processes are in different geographical locations and they are all different machines, they belong to all different machines, immediately what comes to the front is that every machine has its own memory, and the process running in that particular machine uses that memory. Therefore, the memory of one machine is not accessible to the memory of the other machine, and therefore, the two processes running in two different machines do not have what is called a shared memory. So, this makes the communication between these processes harder. So, what is the mechanism that a distributed environment uses? The distributed system uses what is called a message passing. So, one of the processes which wants to communicate would pass a message to the other process, and that the receiving process will again have to pass a message to either reply to the message that is received by the earlier process, or simply to acknowledge that yes, the message has been received by me. So, this mechanism is called the message passing mechanism. Here is a simple example of message passing mechanism. Assume that there is a process A which is running in some machine, and there is another process B which is running in a different machine, and these two are trying to communicate with each other. So, first A has to build a message, because this is not a simple data, it has to go through the process of building a message, putting it in a certain format and such intricacies that we will discuss later on. So, the process A builds this message along with the data that it wants to pass in its own address space in the machine where it is running, and then it executes a system call to tell the operating system that I have a message, and this message has to be sent to the other machine or other process. The OS then takes up the job of taking this message from process A and sending to the process B, which is running on top of another operating system in a different machine. To achieve this purpose, the operating system uses the networking, underlying networking that essentially connects the machine of process A and machine of process B. So, now what will happen is that the networking becomes a very important aspect of having the communication. So, let us take a look at what is networking. In a computer, network is defined as a collection of computing devices that are connected in various ways in order to communicate and share resources, which means that when the two machines where process A and process B are running, these two machines want to talk to each other to allow process A to communicate with process B. The underlying networking using which these two machines are connected will be used to make this communication work. Typically there are physical wires, and of course, there are wireless connections as well, which are used by the networking. The client server model has proliferated because of the underlying networking. So, let us look at this. This is my client A, and there is another process which is the server, which is the process B, and this is in a different machine. When the client wants to get some information, it sends a request to the server, and the server after receiving the request will send a reply to the client. As we already have said that this reply may either be actually the data for the query that was sent by the client, or it could be just a simple acknowledgement saying that I have received and I am in the process of finding out the data required by your request. So, why should the client communicate with the server? Typically, it is the information sharing or the data communication that requires the communication. So, what is an internet? Internet, according to Wikipedia, is the interconnected computer networks, which is a global interconnected computer networks, and it is also called the network of networks. It consists of thousands of networks which may belong to either government or some specific organization or even to individuals. The important part of internet is that it typically uses the TCP IP suite to link devices worldwide. So, since TCP IP is an important part, let us we will look at the TCP IP, but before that let us understand who actually owns the internet. No single person actually owns the internet. In fact, it is not governed by any specific set of rules, but there are sets of protocols following which various machines interact with each other. So, it is a wide area network, and many smaller networks are part of that wide area network, and these may belong to individual persons and organizations. They really define how the connections between these networks should be made. So, why we are interested in networking and in internet at this point in time? Because we have already established that cloud is essentially a distributed system, and cloud communicates between the client of a cloud and server of a cloud. The communication happens over the internet. So, unless we understand how the internet communicates, we really do not understand how the cloud communicates. So, its close relationship with the internet is that the clients connect with the service providers using internet, and also the service providers servers are or may not be necessarily located in one data center. Typically, a service provider, for various reasons, a cloud service provider develop data centers which are geographically dispersed. They do this to avoid natural disasters, they do this to ensure availability, they do this to give 100% security to the client's data. So, these data centers also need to communicate with each other, so that they exchange data and exchange information among the data centers. So, the servers are connected with each other using internet. So, between two data centers also, when a server wants to connect to the other server, they use the internet for this kind of communication. So, let us look at the TCP IP suite which is used in internet protocol. So, here there are 4 layers, which is the application layer, transport layer, network layer and the data link layer. This may be the sender or the receiver, may be either client or server, and this is the other machine having similar identical 4 layers, and these are connected using the physical layer. Now, the network is connected using what is known as internet protocol or IP, and the transport layer is connected using either the TCP or the UDP. Since the communication is to be reliable, we typically use the TCP, because TCP is reliable and TCP is connection oriented. So, it satisfies the integrity property of any reliable communication by doing what? It uses checksums to detect and reject corrupt packets, and it uses sequence number to delete and reject duplicate packets. So, TCP being a connection oriented protocol, it uses the mechanism of ensuring that each and every packet that has been sent by the sender has been received by the receiver and vice versa. So, essentially internet networking is unreliable, which means that there are routers which when they get congested, they have the habit of dropping packets. So, therefore, when a client or a machine sends a packet over the internet, there is no guarantee that that packet arrives at the destination. But when we use the TCP protocol and in our transport layer, it ensures that every packet that has been sent by the sender has been received by the receiver. And also this is done by using multiple communication of the same packet. If at any point in time the TCP protocol discovers that a packet has been lost, or even suspects that a packet has been lost, it retransmits a packet by using the method of timeout. Unfortunately, this gives rise to the fact that there may be multiple or duplicate packets. The same packet may be received by the destination a multiple number of times, but TCP itself ensures by putting sequence number to these packets that only a single packet of any type is delivered, and it is delivered in the same sequence as has been sent by the sender. The validity property also is checked by the TCP by using timeouts and retransmissions. Therefore, messages that are sent will be delivered correctly and in correct order without being affected by the packet loss of the underlying networking. That is why TCP is called a reliable protocol, and if our cloud requires that certain communication has to go with 100% reliability, then the protocol that we need to use in the TCP/IP suite is the TCP protocol. However, many applications require that the communication happens faster, and there are quite a few applications which do not need the reliability as is defined by the TCP very stringently. So, therefore, the other transport layer protocol, which is the UDP, which is unreliable and connectionless, is also used by many cloud system. AWS, for example, uses UDP to a very large extent. On the other hand, Google App Engine does not allow UDP to be used, it only uses TCP. So, depending on the kind of reliability that is required by the environment, we can decide whether to use a TCP cloud or a UDP cloud. Let us come back to the basic requirements of distributed communication. Since it is a very large system, first we have to understand who all are trying to actually communicate with each other. So, let us look at the entities that are trying to communicate with each other. The first entity is an object. In an object oriented world or object based world, the objects are the entities which want to communicate with each other. they have an interface definition language, or which is called an IDL, and this is the basis of object communication, and they require specific methods of communicating with each other. Then we have the components, because many large distributed environment are built using, may not be using objects, but using components which are defined by their own component technology. These components will be the entities that need to communicate with each other. They have clearly defined functions, and they have very clearly defined interfaces through which the communication has to happen, and the components also are very clear about what they expect with the other components in the environment. So, component based technology has been very amply used by the developers of distributed environment. So, all dependencies in a component environment are explicitly defined. The third entity that is there very much present and an important presence in a distributed and very of course in cloud are the web services. Now, web services are very important part which or entities which require communicating with each other. They also have a very appropriate encapsulation and a very well defined interface. So, the web service is defined by the Worldwide Web Consortium as it is a software application. It is identified by URI whose interfaces and bindings are capable of being defined, described and discovered as XML artifacts. Because XML is an internet is a message exchange protocol, it is very easy for web services to communicate with each other. Now, let us look at the paradigms that are used in a distributed environment for their communication. Essentially, there are three paradigms. The first one is called the inter-process communication, the second one is called the remote invocation, and the third one is called the indirect communication or group communication. So, what is an inter-process communication? It refers to the rather low level support for communication between processes. As we said that these can be communication between various objects, or it can be communication between various components, or it can be communication between various web services that are running, and it includes the basic primitive message passing interface, and they typically use the predefined interface requirements and communicate with each other. Also, part of interprocess communication are multicast communication, and we will look at multicast communication in details a little later. So, interprocess communication is a very important aspect of a distributed environment and therefore of cloud. Basically, there are two reasons for which interprocess communication is used. It uses of course for exchange of data and information. Sometimes or many times it also tries to in an attempt to coordinate various processes in a distributed environment, they use the interprocess communication. So, using this interprocess communication, a distributed system becomes a distributed becomes a single entity in spite of being a distributed environment. So, therefore, various processes or entities are strewn all over the globe. They are running in different machines in different environments, and because there is a very well defined method of allowing these entities to communicate with each other, the overall environment looks like one single system to all its users, And as we already have seen that transparency is a very important characteristic of a distributed environment, and because of transparency the complexity of communicating processes running in different machines are completely hidden by the environment. So, the next paradigm is called the remote invocation. The remote invocation covers a range of techniques. It is a two-way exchange process. So, one method will be invoked remotely from one machine to the other machine, and the results of the calling process will be sent. There are many forms that can be used for remote invocation. The first one is called the request reply protocol. In request reply, it is the simplest and essential mechanism of message passing. Typically, it is a pairwise exchange of messages. So, when a client sends a request, a server responds to that request, and this pair of a request and a reply is the basis on which the request reply protocol is formed. It is a primitive paradigm, and not since it does not have the elegance or the complexity, therefore, it is typically used in small embedded systems which can survive on this. The next one, and a very important one, is the remote procedure call. This is a very elegant communication mechanism used by developed by Birrell and Nelson in 1984. In RPC, the remote procedure is called by a procedure as if it is a local procedure call. So, the complexity of the mechanism is hidden by the concept of a local procedure call. The server offers a set of operations, and the client simply uses those interfaces and executes them as if locally. So, it hides many complexities. It hides the complexity of distribution, the fact that the procedure is distributed in other geographical locations. It hides the complexity of sending and receiving a message over the internet. Therefore, there is a process of encoding and decoding. There is a problem of the other machine not being able to understand the mechanism of this machine, and the complexity of the essential message passing over the internet without compromising on the semantics or the meaning of the message. So, here are the steps of RPC. First, the client calls the there is a the client process gives a procedure call to the client stub, which is another process running in the same machine. The client stub takes the trouble of building the message and calling the local operating system on the machine where it is running. Then the client's OS sends the message to the remote operating system. The remote OS delivers the message to the stub. This is still in a format not understandable perhaps by the receiving process. The server stub will unpack the parameters, and then server is called. The server executes and returns the result, and it comes back in a similar path. Here is an example where it shows this is the client machine and this is the server machine. The steps are the local call, and then the stub is doing the marshalling, and then it is being sent. Then the server stub is obtaining the call. It is unmarshalling and giving it to the server process. The server process sends the result, and the stub sends it to the OS. The OS then sends it to the client OS. Client OS delivers it to the client stub, and client stuff delivers it to the client process. So, typically RPC will be made reliable by the use of the TCP protocol as its transport protocol. The third one are the remote method invocation. It is essentially the RPC in the world of distributed objects. So, in an object based world, a similar method is used to execute the methods of a remote object, and that is the mechanism called RMI or remote method invocation. The third paradigm is the group communication. In a group communication, the sender may be one, but the receiver may be a number of processes running in different machines, and this one process is sending a message to a group. The characteristics of how the group is receiving this message, in what order these messages are received, and how the mechanism is organized is the mechanism of group communication. Typically, it is the abstraction of a group on which the group communication mechanism defines. So, in today's session, we saw the essential difference between the uniprocessor and multiprocessor or a distributed environment, where the basic difference comes because there is no shared memory in a distributed environment. Then we saw that networking influences the distributed communication, because all the communication in a distributed environment has to depend on the underlying networks. We saw that internet is the mechanism for obtaining the communication, and that uses the TCP IP suite. We saw the various entities in a distributed environment that communicates with each other, and we looked at the three paradigms, which are the interprocess communication, the remote invocation, and the group communication. In the next module, we will look at in further detail the group communication, since it is a very important mechanism.